So for section 9.3, we're looking at percents. What percents are? They're a type of fraction. So they're a fraction with a denominator of 100. And that's all that they stand for. So for example, if you have 17%, well, that just means 17 over 100. That's all that is. Now this can get a little interesting. For example, if you have this, if you have 0.25%, well, then this would just be 0.25 over 100. And we'll have to deal with this special case later. I'm just going to circle it for now. What we ultimately want to do is not have a decimal in the numerator. So we'll talk about that. Now, first off, we're going to do conversions with percents. So to do conversions, we're going to bring in a couple ideas. Times 100. This moves your decimal point 2 spaces to the right. So, for example, (6.25) times 100. Will be 625. So that's a trick that's going to be helpful with this. Another one. Dividing by 100. This moves your decimal point 2 spaces to the left. So for example, if you have 6.2 over 100, which is the same as dividing by 100, we'll move once, we'll move again. We get 0.062 or 62 thousandths. So questions about that? And since we are working with decimals, I'll just make this a general observation. Every times 10 moves decimal a space to the right. And every division by 10 moves decimal point a space left. So let's look at this. So first, let's go.
Okay, I'm sorry. I didn't have enough time to write those the last two things that you just wrote. It was every times 10 moves decimal point to the.
Oh, so each times 10, that'll move the decimal point one space to the right, but each division by 10 moves it one space left. And that's going to be helpful. We had this one earlier. We had a problem earlier. We had this point, what was it, a 0.62 over 100. To turn that into a fraction without a decimal in it, we're going to use this one. So this does sort of come back. And where it's helpful, you can think of this one. If you divide by 1,000, for example, well, 1,000 is 10 times 10 times 10. So you have 3 10s multiplied together. So that means if you're dividing, or actually put it to you this way, sorry. You're going to be dividing, let's say you have 6 over 1,000. You're actually dividing by 3 10s. Now, granted, these 10s are all multiplied together here, but each one of them will be divided into that 6. Since each 10 is divided into that 6, one, 2, 3. You'll get 0.006. So this is just kind of it's really a way of just moving your decimal point when you're working the decimal system. If you need to move it to the right, multiply by 10. If you need to move it to the left, you're going to divide by 10. And 1,000, you have 3 10s, so you'll be dividing by those 3 10s. So that moves that decimal 3 spaces to the left.
Awesome. Okay, cool.
Awesome.
Thank you.
No problem. It's just one of these are little tips that'll help. It can help sometimes. So one of the things we're going to look at, percent to decimal. And if we recall what a percent is it's just a fraction over 100. Now 100 is 10 squared. There's 2 10s multiplied together in 100. So that means with a percent, we're always dividing by 100. So that's got 2 10s. So that means we're going to move the decimal 2 spaces to the left. So for example, %, we're just going to take 35, and decimal will go right here, and we'll move this 2 spots to the left. 0.35 or 3500ths. Let's say we have this. %125. Well, same idea. Move that decimal 2 spots to the left. We'll get 1 in 2500, so 1.25. And you could get something like this. Now this started out as a percent. A little more room here. So we're going to do this. Still go to the left. You're going to get something like that. So that's how we go percent to decimal. Now the other way is decimal to percent. So the way this works is we're just going to do the reverse of turning a percent to a decimal. Instead of moving the decimal point 2 spots left, we're going to move it back. And that means moving it 2 spots to the right. So go 2 spaces right. So for example, let's say we have 0.05. Well, to turn this into a percent, we move the decimal point 2 spots to the right. And so this will give us 5%. So any questions about this? And I meant to put an equal sign here. I'm just going to slip one in. There we go. So let's say we have this. Let's say we're going to convert 2 into a percent. Now this is just the number 2, it's not 2%. So what we do here, we can call this 2.0. And this 2.0, To make it a percent, we got to move the decimal 2 spots to the right. And so what we'll get is 200%. Questions about that? So finally, let's say we have this. So we got this decimal. We want to make it a percent. So we'll move that decimal two spots to the right. And we're still going to have a decimal. Not even greater than 1, but that's okay. That's just fine. So questions about that? So that's going between decimal and percent and decimal. And every time we're moving our decimal to the left, we're actually dividing by 100. Every time we're moving it to the right, we're doing the opposite of dividing by 100. We're multiplying by 100. Now, the other conversions we're going to run into are fractions, and we kind of got a hint of this already. So percent to fraction. The way we do this is we just convert the percent into the fraction using the definition. So for example, 19%. Well, a percent is just a fraction with a denominator of 100. So this will be 19 over 100. Now, let's say there's something like 5%. Well, again, we can write it as a fraction. This will be 5 over 100. But this is a fraction we can reduce. 5 will divide into 5, and 5 will also divide into 100. So 5 divided by 5 is 1. 100 divided by 5 is 20. So this fraction reduces to 1/20th. Questions about that? So let's say we have something like this. Well, again, we're going to write this as the number we're given over 100. Now we want to get rid of this decimal. So we want to move the decimal 2 spots to the right. So the way we can do that we can multiply by 100, top and bottom. When it comes to working with fractions, we have to divide top and bottom by the same number, or when we multiply top and bottom by the same number. And note, $100 is 10 times 10. So we're multiplying by 2 10s, multiplying by 2 10s. That moves that decimal 2 spaces to the right. So we'll get 65 over, and 100 times 100 is 10,000. And again, the reason we do this, whatever we do to the top, we've got to do the bottom when we're multiplying and dividing. So let's see here. Well, this is divisible by 5. So again, what we do to the bottom, we do to the top, and vice versa. So 65 divided by 5 is 13. 10,000 divided by 5 is 2,000. Now 13 is a prime number. I'm pretty sure 2,000, let's see, doubtful it's divisible by 13, unless I'm in for a, no, it's not. So this is as far as we can go. Questions about that? All right. So here's another one. And this one, let's say you have this. (1/4%). Well, again, we'll take 1/4 and we place it over 100. Now we're dividing fractions. So this large fraction bar, it means a division. So divide fractions, we do what's called KFC. Keep the first fraction, we flip the second one. So if you flip 100, you can think that all whole numbers, 6, 7, -4, 100, all whole numbers have an invisible 1 underneath. Because 100 divided by 1 is 100. So we can flip 100, we get this. So we keep, we flip, and then we change the C into multiplication. So multiplying across, we get 1 over 400. Questions about that? Now you might get something like this. I got a mixed number. Now what I recommend with mixed numbers, you have a whole number, a numerator, and a denominator. Convert these to improper fractions. Whole number times denominator plus numerator, that's the top. And the bottom is that same denominator. So for this one, we'll have 4, 3 times 4, plus 1, 13/4%. Now again, we're trying to turn this into a fraction. So this is just the first step. Now, take our 13/4%, and because we're turning this into a fraction, what we got to represent it as 13/4 over 100. Again, that's what a percent is. It's whatever this is over 100. Now again, we're dividing fractions. So this is 13/4 divided by 100. We do our KFC. And then multiplying across. And That's the fraction. And that won't reduce. There are no common factors in 400 that will then have a 13. None of them are 13. And 13 is a prime number. So 3 1/4% is really that fraction. Some questions about that. Now, what if we're going the other way? Well, let's say we're going fraction 2%. There's a number of ways. The way that's typically done is we'll do this. We'll go fraction to decimal. So we're going to actually use the division property. The fact that fractions are division will come up with a decimal. And then we'll go decimal 2%. For example, let's say we have this. I want to turn this into a percent. Well, first off, we're going to divide. So 4 goes into 30 at most 7 times. 7 times 4 is 28. 2. I'll bring in a 0, drop it down. And then 4 goes into 20 5 times. 5 times 4 is 20. Subtract is 0. So what we get is 0.75. I'm just going to circle it. I'm not going to put a box. So that's our first step. We've converted our fraction using division into a decimal. Now we're going to convert our decimal to a percent. And again, the way we do that is we move our decimal point 2 spots to the right. And that's going to be our answer. So any questions about that? All right, now let's say you have something like this. So again, we're going to convert this to a percent. We need to make it into a decimal. Decimal point up. So 3 goes into 10 at most 3 times. 3 is 9, subtract 1. And what we're going to see is that this is going to repeat. We'll keep doing this forever and ever. So we're just going to get 3's. And so what we can say is this is equal to 0.3 repeating. Now, when we do the conversion here from decimal to percent, you want to be careful. It'd be tempting just to do this and put in zeros, but that's not what's going on here. This isn't 0.3, this is 0.3 repeating. So we need to put in some 3's. And then when I stop putting in 3's, this is a little note that says I should be listing them on and on forever. So now, if I move my decimal, we get 33.75. 0.3%. So with repeating decimals, you do want to be careful when you move that decimal point. You want to expand some of these decimals, or some of these numbers rather, get some of these digits listed out, and then move your decimal point. All right. So finally, let's say you have this. Now, there's a couple ways of doing this. So one way of doing this is to convert this into a decimal, and then we're going to add it on. So let me show you what that is. So this is method one. Mixed numbers, what they represent is a whole number plus a fraction. So what we can do is convert the fraction part. And we've seen this before already. Oh no, I don't think we've done this one. Maybe we did. No, we did 3/4, I think. So we get 0.25. So next what we're going to do, that means 2 plus 1/4. That's really 2 plus 0.25, or 2.25. So now we get to step 2. Now we move that decimal point. So this is a decimal number. We go 2 spaces to the right. We get 225%. So that's the first method of doing this. Now let me show you the second. If I'm going too fast, let me know. So method 2. Method 2 is we turn this into an improper fraction. So W, N, and D. So there's D, and then we have W times D. So 2 times 4 plus N, or 9/4. Then we divide. Two times 1 is 8, subtract is 1. Add in. Add those 2 times 4 is 8. Subtract is 2. Bring that in. 5 times 20, 0. So we get 2.25, which is the same decimal we had before. Then what we're going to do for step 2 is just move that decimal point 2 spots to the right. and that's going to be your answer. So questions about that? All right. So those are the conversions with percents. And that's sort of the first part of the section. The section sort of falls into three parts. You have first part, the conversions. The next part is we're looking at a particular formula. So let me pick that together here. So this is where those equations we had in section 9.2 with proportions, this is where these become pretty powerful. We can solve these the same way. The issue we're going to run into is how to set them up. And we're going to use this formula. Percent over 100 equals amount over base. So percent over 100 equals the amount over base. In the way you can kind of picture why this works, let me give you an example. Now the fraction 1/4 is equal to 25%, or the decimal 0.25. So what we do, the amount is going to be the 1. The base is the 4. The percent is 25. Not 0.25, but this 25. So when we put this together, what we get is 25 over 100 equals 1 over 4. And 25 over 100, that's 0.25. So that's roughly where this formula is coming from. Now the types, any questions about that? Now the types of problems we're going to be getting, the percent, the amount, or the base are going to be missing. I'm going to use an abbreviation, PAB. Now this 100 under the percent, it'll always be there under the percent. It'll never go away. So this is always a given. We'll also be given 2 of these. One of them is going to be missing. We got to solve for the missing one. The tricky part is this usually comes in the form of like a story problem. So we have to be able to identify the amount, the base. The percent's not too hard. They'll frankly just tell us. But figuring out if we're dealing with an amount or a base can be a little tricky. So let's take a look. That means we got 3 types of problems that show up with this kind of formula. Let's see. So let's say the average size, I'm just using the examples from the text here, but the average size of a new single-family house in 2014 was 2,690 feet square. This is 158% of the average size of a new house in 1980. So we want to find the house in 1980. How large was it? So this one's kind of tricky. So for the percent, it leaps out at us. We've got a percent sign. So P 158. Now, the tricky part is, and this is going to seem kind of odd because we're dealing with 158%. So this is a part, quote unquote, that's bigger than the whole. So when we say something is a percent of something else, this first thing is the part. Usually a part is only a percent of a whole. Because this is 158%, the part's bigger than the whole. We have some extra credit here. So the part, or the amount, is going to be this. And then this is going to be an amount of a whole, and we don't know the whole. So that's going to be unknown. So we put everything together. P over 100 equals A over B, or 158 over 100 equals 2690 over B. So the way we can solve this is cross multiply. So we get 158B will be 2690, and we're multiplying by 100, so we'll tack on a couple zeros there. Divide both sides by 158. We'll get B. Let's see, what do we get for B? Approximately 1,703 square feet. And so that's going to be our answer. Questions about that? So that's what we needed to identify the missing base. Now let's take a look at the different one. Let's say, let's see here, well, the percent, let's see if a missing percent. So let's say according to the Bureau of Labor Statistics, the average family income is $66,877. And of this income, $6,759 spent on food in a year. So what is the percent? So what we have here, we're starting out with $66,877. Part of that money is being spent on food, $6,759. And we're missing a percent. So right away, percent, we don't know. Now, the amount or the part is the $6,759. And the base, or what we're taking this out of, or what we're comparing this to, that's the 66,877. So again, we're going to set up P over 100 equals amount over base, or P's unknown, but we have 6759 over 66,877. Now again, we're going to cross multiply. So 66,877p will be, and I'll put the multiplication in here. Won't skip that step. But what you're going to do is just tack on a couple extra zeros, the 6,759. And there we go. So we're going to do this division. And if we do the division, P come out approximately to 10 or 10%. So questions about that? Right. So we've looked at when the base is missing. We've seen when the percent is missing. Now let's think about the amount. So let's say we have this. Let's say there's 7.3 billion people. 32% of this 7.3 billion do not have access to improved sanitation facilities. So what we want to find out is, how many people is this? All right. So the trick here again is we want to identify the percent, the amount, and the base. Well, a percent's easy. That's 32. Now I want to look at amount and base. Well, we have 7.3 billion people, and we're interested in 32% of that population. So we're interested in a part or an amount of the entire population, but we're not told what that amount is other than given in percent. So the amount is unknown, and our base, 7.3 billion. So a trick here, you could write 7.3 billion. You could do this. You could write the number out like that and then do your mathematics, or you could just leave it as 7.3 and then remember that whatever number you get is really a number in billions. So if you got a number like 0.5 for your answer, that would be 0.5 billion. So you'd have to make that conversion, which is actually 500 million. But you could just leave it like this and just, the math is a little easier. So we have percent over 100, round over base. So the percent, 32. The amount we don't know, but the base will go with 7.3. And just remember, the amount is going to be in billions. So again, we're going to cross multiply. So let's see, 32 times 7.3 is 233.6. It's equal to 100. Divide both sides by 100. And let's see, we're rounding this. We won't do any rounding. We'll move our decimal 2 spots to the left because we're dividing by 100. And that's going to be A, or 2.336 billion. And so that's going to be your answer. Now, I'm not sure in the homework, what they might do is just have this typed out for you. You just have to fill in the number. So you might not actually have to type billion in your answer. They might even mark it wrong if you do, if they've already got it for you. All right. So there's actually 4 parts to this chapter. The last 2, the percent equation. So any questions about this? Now the percent equation works like this. Let's say you have, again, P is percent. A is amount. And B is base. Now, in the percent equation, and in some ways, I'm going to use a lowercase p here. In the text, they use a capital P, but the reason that we use lowercase, this is percent as a decimal. So when we deal with the percent here, we're dealing with percent as a decimal. So the formula we're going to get, the percent as a decimal times the base equals the amount. And just like with the percent proportions, you're going to be given two of these and solve for the other one. So I'm just going to do one example. So let's say we have this. 25% of sales was $342. So let's say we want to find out what was the total sales. So just like with the proportion, what you're going to need to do is identify the part, the base, and the percent, or the amount, the base, and the percent. Well, the percent's easy. So the percent, it's 25%, but we got to divide by 100 to make it a decimal, or move that decimal point 2 spots to the left. So you want to remember to convert this to a decimal. Now the amount, or the little part here, 25% of the sales, that's just a portion of the sales, just a smaller amount. And that smaller amount is 342. So that's going to be our amount. And then what's the base? What's the total? Well, that's what we're looking for. So that's going to be unknown. So now we put everything together. Our PB is equal to A, or 0.25 times B is equal to 342. We'll divide both sides by 0.25. Let's see here. We'll get B is $1,368. And so that's going to be your answer. So when you're working with this percent equation, it's going to be very similar to the proportions equation. You want to identify your percent, and then except for this one part, the percent's going to be a decimal. And then you want to identify your base and your amount. So I'll do one more with this one. When you're looking for the percent,
I'm sorry, I'm just having difficulty understanding how we got, we had the 0.25 on the base, and then you wanted that multiplied by the 3.42. How did we get the 1368?
So what we did, we divided both sides by 0.25 because we want to do the opposite of what's going on here. Whenever we have a number next to a variable, that means we're multiplying those together. It's just an algebra thing, but we seem to always leave out the little multiplication. It's just something they do in algebra. The opposite multiplication is division, and you're good to go. And that's it.
Awesome. Great. Sorry, thank you.
No problem. So let's say $25 in commission was earned from $2,500 in sales. So $25 in commissions earned from $2,500 in sales. What is the percent for the commission? So $25 in commission was earned from $2,500 in sales. What is the percent for the commission? Now, again, we're going to look for P, A, and B. Well, right away, we don't know what the percent is. In fact, if they tell us that's what we're looking for. So that means unknown. Now the amount, this is going to be some part of a whole, or it's going to be an amount from the base. And the amount, we get $25 compared to $2,500 in sales. So our amount is going to be 25. And then the base will be 2,500. So now that we have this, we have our PV equals A, or P times 2,500 equals 25. Or to write it more canonically, we always put the variable behind the number. So again, what we're going to do, we're going to divide by 2,500 to solve for P. And when we do that, we get P is 0, 0, 1. Now, we want to be careful here. This is percent as a decimal. So we got to convert it into a proper percent, a capital P. So what will happen, we'll move our decimal point 2 spots, and we'll get 1%. Okay. So questions about that? With this little p in the percent equation, you want to be careful. It's always acting as a decimal. That's different from the capital P in the percent proportion, where capital P is a full-blown percent. All right. So the last thing to mention here percent increase and decrease. So what we're going to do, we're going to use the percent equation. So again, we're going to bring this back. And what we're going to do is that P, again, is going to be our percent increase. B is going to be our starting amount. Or starting base. Now, A is going to be interesting. The way we calculate A, it's the ending base minus the starting base. It's going to be the ending base minus the starting base. So questions about that? So let me do an example on this. And there's a slightly different change for percent decrease. The difference is we'll just have a starting base minus an ending base. And we'll get to that in a second. So there's a lot of talk in the news about increasing the minimum wage. Now let's say you increase the wage from $10.50 per hour to $12 per hour. So the question we would have is this. What is the percent increase? So we're going to take a minimum wage of $10.50. We're going to increase it to a minimum wage of $12. What is the percent increase? Well, sometimes they'll play a trick with you on this. Instead of saying percent increase, they might say percent change. And if you've noticed, we have a smaller number that becomes a bigger number. So that means something's increased. So that percent change would be a percent increase. So let's take a look. Now, the percent, and again, since we're using the percent equation, where this is going to be as a decimal, in decimal form, we don't know. We're looking for that. Now, the starting base, because we have two bases here. The starting base is going to be the number we start with. So that's going to be 10.50 or 10.5. Then the amount, it's the ending base minus the starting base. So that's 12 minus 10.50 or 10.5. That's going to be 1.5. So now we have all the parts. Now we use that equation. So we don't know this one. We have this. That's 1.5. So to solve for P, we're going to divide both sides by 10.50. If I'm going too fast, let me know. And so what we're going to get is P is approximately, I'm going to round this off, about 114.29. Now, again, this is the percent in decimal form. We have converted to the full percent. Increase would be 14.29%. Questions about that? All right, so that's the idea of percent increase. The other one is, oh, let me see. I think it's working still. I just got one of those messages that says the connection's not good. But I think it's all right.
It glitched a little bit for a second, but it should be okay. Oops, it's glitching again. Yeah, it's glitching.
Oh, okay, it looks like is it okay now?
Yeah, I can see you okay.
Okay. Well, there's one last type of problem, and ooh, it might. Let's see. It's giving me that message again. We'll see. So percent decrease. So the idea here again, lowercase p is a percent. Again, B is going to be a starting base. Where this is going to be different is that the amount will be the starting base minus the ending base. So that's going to be the big difference with percent decrease. So let's say we have this. So let's say we've got a pair of running shoes and they're on sale. Now they usually cost $60, but now they're $38. So what is the percent decrease? Now again, they could just say percent change. And the way you know it's percent decrease is you have a starting number that's bigger than your ending number. One of the things to keep in mind is your amount here, at least for these types of problems, we're going to keep the amount positive. So to keep amount positive, smaller number is going to get subtracted from bigger number. The bigger number is what we start with. Ending number, that's the smaller one. So that tells us we're decreasing over time. So finding out what is what, again, percent, we don't know. That's what we're trying to find. Now the base, the starting base is $60. And the amount, well, for percent decrease, it's starting base minus ending base. So starting, this is what we're ending with. It's at 60 minus 38, or 22. So now we have all the parts. We just plug them into the formula. And again, the solve for P will divide both sides by 60. So again, we're getting a decimal number. Let's see what this turns out to be. It's going to be repeating. So again, we want to move our decimal 2 spaces to the right. And since this is a repeating number, I'm going to want to make sure I've got enough digits here to move that decimal into. And so this comes out to, actually it's going to come out exactly 63.33 repeating percent. And that's going to be it. Questions about that? So that's 9.3. Now it's got a lot of material in it. I mean, you're converting those percents and the decimals to percent, percent to decimal, then fraction, percent to fraction. You've got your proportions questions. You've got your percent equation question. You have your percent increase and your percent decrease. So if you have any questions on this, let me know. Other than that, that's it. And don't forget, we have the President's Day off on Monday, and I'll see you on Tuesday. Unless you have any questions, let me know. And other than that, have a wonderful day and a wonderful weekend.